Alright, we'll start with the sum of a finite arithmetic sequence for 9-2, day 2. So what I'm going to do here is give you this formula to get the sum of a finite arithmetic sequence, and then actually when I get down to the first example, I'll explain a little more as to how it works. But here's what it looks like. The sum of those n terms equals n over 2 times a sub 1 times a sub n. N, of course, is the number of terms in your sum that you want. That number will typically be specified. And then over here, we have first term. And you could say the nth term, but I think a better way to describe it is the last term. We have to know what that is because we're interested in what the first term and the last term add up to. Let's hop down here and I'll show you how it works. Now, first of all, down below, I'm just going to use it and just quickly get the sum that I've got. Well, first of all, the pattern is arithmetic, which is important to note that if we notice a different pattern where it doesn't have a common difference, then this formula doesn't work. But this one does. The sequence starts at 1 and D is 2. So it's a fairly simple arithmetic pattern. Once I identify that, I'd see we're talking about 10 terms. So I'd have 10 over 2. The first term in my sum is 1. The last one is 19. That simplifies to 5 times 20. Those 10 numbers add up to 100. Okay? Now, as far as how it works, really the focus is right there, that we split this up into 5 times 20. There are 5 ways you can take these numbers and add them up to 20. The first term and the last give away that sum of 1 plus 19. Now, if we start to work our way in, the next terms available would be 3 and 17, 5 and 15, 7 and 13, and then 9 and 11. Okay, notice those all add up to 20, and because I paired the numbers up, we ended up with 5 pairs, right? Because we started with 10 terms. So from pairing them, that's where I really get this 5. The first and the last told me the sum that I'm getting is 20, and this is going to break down to 5 sums of 20. Okay, that's really the big idea of how this formula works. Now, I like to look at this one because you might see that one and say, well, that's great. Your formula is all wonderful and everything, but just, add those terms up. Sure, right? That's a little, it was only 10 terms. That's a little bit smaller. Let's say the first 1,000 whole numbers. All right, that's obviously, unless you have a lot of time on your hands, going to be pretty impractical to add those up one term at a time. So what we're really doing here is saying 1 plus 2 all the way up to 1,000. That's really what's going on, though. It's one of the simplest arithmetic series that you could have. You're starting at 1, and your common difference is 1. It's really Nothing major if we know how to apply the formula. First term is 1. The last term in my sequence would be 1,000. I'd have 500 pairs of numbers, and each of those pairs would have a sum of 1,001. $5,500. Now this one has a little bit of a difference to it. A little extra element. We want the sum of the first 150 terms. So this is definitely a little bit bigger sum. It starts at 5. It's going up by 11. But this gets to be a little interesting. I got to split this one up in 2 parts. Because down at the bottom here, if I did my sum, I'd say, all right, I have 150 terms over 2. First term is 5, and then here is where the issue comes up. What's our last term? You know, I see where it starts, I see the pattern that it's going up by 11, but at the moment, I don't know, because those first 2 examples we did, we kind of had the last term of the sum. And here we don't, which is not that big of a deal, we just have to find it. Think back to the previous day with our formula for a sequence. 5 plus n minus 1, n of course is 150 times d. So you could have to figure it out, but that's really a sequence question, right? If you were to start at 5 and add 11, where would you end up after you listed off 150 numbers? That would be 1,644. And once that number goes in here, all is well. We would say 75 times 1,649. And there we go. $123,675. All right, in our golf tournament, we've got 16 golfers. We have kind of an interesting prize money situation because for this formula to work, it needs to follow an arithmetic pattern. Most golf tournaments actually don't, but whatever. This is ours, and we're going to. Winner gets $1,000, second gets $950, third gets $900, and so on. All right, so we want the total amount of prize money. It said there was 16 players. So I'm going to dive right into the sum. That's what I'm looking for, S sub 16. Side note here, it's kind of occurring to me, looking at the last 2 examples we're going to do, I've used an even number of terms. The formula works exactly the same if n is odd. So if this tournament had 17 golfers, it wouldn't change a thing. You would change n from 16 to 17 and it would work just as well. First term of the sequence is 1,000. D, be careful with that one, it's negative 50. So I've got 1,000 there, and basically the same problem comes up again. I don't know at the moment what 16th place, if we're being kind, last place if we're not, what they're going to get. can easily figure that out, as we would have 1,000 So two really different things going on here that could be a little confusing. A sub 16, and I think the context here helps to talk about it, is the prize money for last place. Let's be nice, 16th place. It's a prize money for 16th place. The original question is, what is the total payout to all 16 golfers in the tournament? Okay. I think it's important to recognize those are two different questions. The answer to the first one is 250. The formula that we're seeing today, which would basically break down to 8 times 1250, that will give me the sum of the payouts to the entire field, which will be $10,000, is all the prize money going to all 16 golfers. Obviously not in equal amounts, it's all based on their place. All right, last one here. Shrink this down a little. So here I think is a good approach to start with. Based on the context here, she's selling $10,000 worth of skincare products during the first year. That's our first term. The owner would like to increase annual sales by $7,500 a year. We are looking for the sum of her total sales from the first 10 years all added together, which means I am going to need A sub 10. This is again a really good place to talk about the difference between these two calculations. A sub 10 is going to be his or her goal. I don't think it says. It just says business owner, whatever. Their goal for sales in year number 10. S sub 10 is all 10 years of sales added together. We are going to need A sub 10. Right? And you could try to proceed without it, but then you'd be like, all right, n over 2 times sales in the first year, and then, yeah, oh, wait a minute. To do this sum, I need A sub 10. Okay, this is the third one in a row where we haven't been given what it is. We just use our sequence formula. And we get that it's $77,500. And that would go right here. We'd have 5 times 87,500, which would give us $437,500 would be the total sales between all 10 years added together.